The next way we're going to learn is how to solve if it's in vertex form. And this could actually equal anything, really. I'm going to set it equal to 0, but it could be anything. Maybe we should use a different variable. Let's say it was equal to some c value. So we're going to learn how to solve these ones. And these ones are nice because in vertex form, you're just solving like you would any other equation. You're just getting the x alone. You're just going to be getting the x alone. Now, so maybe, you know what, let's go into one example real fast, and then the whole I nonsense, that'll come out once we get one of our answers. So we're actually going to solve first. We're going to go to the examples here. I passed them already. Okay, let's do number 12. Number 12 on page 83. Yo, what's up, 72053? How are you? Don't know who you are, but how are you? Glad you know me and you spelled my name correctly. Thank you for that. All right, so we don't need to get this thing equal to 0 here. We don't need to get this equal to 0. We just got to get the x alone. So to get the x alone, we're going to have to get rid of the square. To get rid of the square, we have to square root. The square root. In order to square root this thing, we want to get it alone first. So first goal is to get whatever is squared. Oh my. Now that I've zoomed in, that is so large. Whatever is squared, our first goal is to get that alone. So we're going to get that guy alone first. To do that, we're going to add 11 to both sides. So we get -2 x plus 4 squared equals 56. And then we're going to divide both sides by -2. We get x plus 4 squared equals -28. Now that our squared term is alone, we can cancel that square by square rooting both sides. So I'm going to draw this square root symbol in here. So I'm going to square that side and that side. That's going to make these cancel. Real quick, we got to go on a tangent here because there's something we have to do with the square root. Now you'll see square roots are used kind of in two ways. You'll see an equation that has a square root in it like this. Y equals something like square root of x. So this is just an equation that already has a square root in it. If I were to plug in a number into that, like 4 for x, to find the answer of that, we would just say it's equal to 2, because 2 is the square root of 4. We call 2 the principal square root because it is the positive square root. The 4 actually has 2 square roots. It has the +2 and -2 is also a square root. Whenever we plug into an equation like this, though, we always just use the principal square root, the positive version. It's different, however, when we are solving for something. If I tell you that x squared is equal to 49, there's two solutions here. There's two x values that can make this statement true. There's two x values I could plug in here. I could plug in -7 because -7 squared is 49, or I could plug in a 7 to get 49. I know, Narwhal. It's like other people have better things. Can you believe that? What else would you rather be doing on a Friday night than watching their math teacher stream math at 8:30? I've got nothing better to do. I don't know what they're doing. So when we solve this, when we're looking for an x value that works here, there's actually two options, -7 and 7. So how we write that is when we're solving, when we need to get rid of the square root, we square root both sides. To cancel the square, we need to include this plus or minus symbol. This plus or minus symbol there. What that tells us is x is actually positive or negative the square root of 49. And the square root of 49 is just 7, so it's x is equal to positive or -7. This notation here means there's actually two answers for x. X equals 7, +7, and x equals negative 7. So there's two solutions. They're just simplified with that plus or minus symbol here. Okay, now that's established. The key here, the takeaway, anytime you draw in a square root symbol to solve for x, you need to include a plus or minus over here. You need to include that plus or minus. Stream math. Later he'll get more. I know, right? We'll probably get more when we do games. Maybe. It's a Friday night, like really. People might have better things to do. I don't think so, but you never know. Excuse me. All right. So back to this problem. So when we drew in the square root to cancel, so we drew in this square root right here to cancel the square, we need to include a plus or minus on that other square root there. Okay, so continuing the problem, we canceled the square with our square root, so we're left with x plus 4 on one side. Those parentheses are actually not necessary anymore because it's just x plus 4. And that's equal to plus or minus the square root of negative 28. Okay, next part. We need x alone, so we just subtract 4 from both sides. Minus 4 from both sides. We get x equals, now that negative 4, you could put it at the front or the back of the equation. We usually like our real numbers, this negative 4 right here, we want that in the front typically, so we'll do negative 4 plus or minus the square root of negative 28. All right, last thing to do here is simplify this guy. You may have heard your whole life in math that you can't square root a negative. That is not true. It's a lie. Your whole life has been a lie. Let's show what this means. Square root of negative 28. So square root of a negative number, number line with 0, 1, 2, etc., negative 1, negative 2. The square root of a positive number will always be on this number line. For example, square root of 5 is somewhere between 2 and 3. So it's somewhere in here, probably closer to 2. So it'd be somewhere like right there. And there's also a negative version somewhere right here, right? Because negative 2 point whatever times itself will equal 5, and 2 point whatever times itself will equal 5. The square root of negative 3, for example, however, does not exist on this number line because there's no negative numbers you could times by themselves to make a negative. And there's no positive numbers you could times by themselves to make a negative. Either way, you're going to get a positive number. That doesn't mean it doesn't have a solution, though. It just means that the solution is on a different plane, a different number line. Yes, Penguin, I believe it's going to be 2i root 7. Yes, I believe so. It just means it's going to be on a different plane. One easy way to think, well, not an easy way, but one way to think about this is if this is my y-axis and this is my x-axis, the imaginary axis is this like three-dimensional axis that goes like out of the paper kind of. So it's coming out this way. Yeah, I went over that too many times. So it's a three-dimensional axis. Those imaginary numbers, the square root of negative numbers, actually lie on this axis instead. And we'll show what that means graphically more in a minute. So how do we represent them? Well, we're going to call the square root of negative 1 I. We're going to use I to represent the square root of negative 1. Which means if I have something like the square root of negative 28, I'm going to run out of room here. Let's move some of this stuff. So if I have something like the square root of negative 28, I could rewrite that as the square root of negative 1 times 28. I can just split up 28 into two numbers, negative 1 and 28. Then we use our product property of radicals that says I can split up two numbers that are multiplied into their own radicals, like this. And since we have a name for the square root of negative 1, it's I can replace my square root of negative 1 with I. So it's I root 28. The last thing to do is simplify the square root of 28. You can use a calculator or what you know about factor trees to say this is 6 times 4, and I know the square root of 4 is 2. Right? Did I do that right? Okay, so I think it should be 2i squared is 6, Penguin. Is 28 6 times 4? No, it's not. It's 7 times 4. Yep, you're right. I'm terrible. 7 times 4. That's why I was wrong. We know the square root of 4 is 2, so we can pull out a 2. So it's I times 2 times root 7. Our 7 doesn't have a square root, so it stays in. And then the preferred method of writing this, just like we write 2x, we don't write x2. We write numbers, then letters. Yeah, you could do 14 and 2 on that, Penguin. Yep, perfect. Similarly, we want the 2 in front of the I. So we'd write this as 2i root 7. This I, all that means is this is an imaginary number. It's a number that's on the imaginary plane instead of on the real number line. It's on the imaginary number line. So square root of negative 28, the same thing as 2i root 7. So up here in our answer, we can replace. We still have that plus or minus there, but instead of the square root of negative 28, we have 2i root 7. And that's your answer. Now, what do these mean graphically? So graphically, this means I'm going to graph this equation right here. Just sketch a graph of it. So it has a vertex at negative 4, negative 11. Go left 4, down 11. It's got a vertex about there. And then since my a value is negative, it opens down. It looks something like that. This equation was asking, where does it equal 45? So 45 is going to be way up here, right? We're going to pretend like it's right about there, even though, and that should be on the left, typically. Even though it's going to be way higher based on my scale, we're going to pretend like it's right there. This question's asking, when does that parabola cross this 45 line? You got a switch? I don't have a switch. Sorry, man. So when is that graph going to cross this 45? Well, obviously, when we look at this picture, it's not going to. But a parabola is actually a 3D shape. So I'm going to pull up a picture of one real fast. Let's just view this image. 1 second while I pull this up. Make it full screen. Okay, here it is. So here is a picture of a 3D parabola right there. So this 3D parabola, if you follow the blue line, that is, you know what, maybe I can, let's add an artistic touch. Yes, please. This line right here, that's your 2D parabola, because it's in the XY plane like this. But notice how that parabola actually stretches out this way and this way. Well, you can't see my arrow because I did white. So when we look at our parabola, it's hard to see in 2 dimensions on just paper. But what that means is that this parabola we have here actually stretches like out of my screen here, stretches out and eventually crosses this 45 line. Okay, and the place that it crosses at these points, -4 plus or minus 2I root 2 at those numbers. Those are the coordinates, the 3D coordinates, if you will, where they cross. Okay, so that's about it, I believe, for this whole unit. I mean, it's all just about getting whatever's being squared alone so that you can square root both sides. Remembering to include a plus or minus when you square root something. And then simplifying a negative radical, or a negative radicand with the I in it. If you can do those, these should be fairly simple to solve. The plus or minus 4 part. Which part on the plus or minus 4? I did this is my example of the plus or minus 4 right here. The Pringle. Yeah, that was the Pringle. The parabolic Pringle. That's what we're going to call that. Probably where they got the Pringle name from. Starts with a P. No, probably not. You're not forgiven, Bobby. I'm disappointed. So the plus or minus, Penguin, is just any time you're solving by square rooting. So like on this one here, whenever you're solving by square rooting, you need to add a plus or minus because x squared has 2 answers, -7 and +7, that equal 49. You always have to do that plus or minus. It's to cover your bases on both of these answers. If I write, here we'll do another quick example here. If I have an equation that says x squared equals 25, what are my possible answers? My possible x's that make this true are +5 and -5. Hold on, my door just like creepily swung open. One second. Eek, cold out there. Yeah. Our door has like the weather stripping's like too. I know, right? It's the weather stripping is like too fluff thick. So every once in a while when we shut the door, it doesn't actually latch. And then if the wind blows just right, it like eerily just kind of creeps open. I caught out of the corner of my eye and it made me startle a little. Okay, so the -5 and +5 are both answers to x squared. So how we account for that when we're solving is when we square root both sides to cancel that square, we put this plus minus here to show that there's going to be 2 answers here. There's going to be the positive version of this answer and the negative version of this answer. Now that problem, specifically for the homework, was, it was actually x plus a number, like x plus, we'll do a different one than the homework. It was like x plus 5 squared equals, say -8. So when we square that, or square root that, to cancel, we have to include a plus or minus here. Then we get x plus 5 equals positive and negative, positive or negative, or positive and negative, square root of -8. And then we move that number over, we subtract it over. So x equals -5 from moving that 5 over, plus or minus square root -8. And then we simplify this, which simplifies to I root 8 And then root 8 is 2 root 2, right? Yeah, 2 root 2. Then you get x equals -5 plus or minus 2I root 2.